Imagine a horizontally scalable database that puts data everywhere your users are. It seems intuitive, but most databases are still light years away from true turnkey global distribution. Azure Cosmos DB offers the first globally distributed multi-model database service for building planet-scale apps. It's been powering Microsoft's internet-scale services for years, and now it's ready to launch yours. Only Azure Cosmos DB makes global distribution turnkey. You can add Azure locations to your database anywhere across the world at any time with a single click. Azure Cosmos DB will seamlessly replicate your data and make it highly available. Azure Cosmos DB allows you to scale throughput and storage elastically and globally. You only pay for the throughput and storage you need, anywhere in the world at any time. As the first and only schema-agnostic database, Azure Cosmos DB automatically indexes all your data so you can perform blazing fast queries. And since no data is born relational, the multi-model and multi-API capabilities remove the friction, allowing you to build with any data model and API. While most database services force you to choose between strong or eventual consistency, Azure Cosmos DB provides multiple, well-defined, intuitive consistency choices, so you can select just the right one for your app. Take off with confidence, knowing Azure Cosmos DB provides guarantees and comprehensive SLAs other databases would never attempt. High availability, consistency, throughput, and single-digit millisecond latencies at the 99th percentile. Your app deserves a globally distributed database service that's out of this world. Welcome to Azure Cosmos DB.
Hey everybody, Jay, welcome back to AzureFunBytes. Thank you so much for joining me. It's been another week of things to learn. And what do we do here? Well, we learn about the people, the products, the process, and all the things that go into an amazing Azure experience. So I've got some new features this week. I got a nice slick background music. Love StreamYard, great product, helps you do some really cool things. This week, I've got some really great guests that are going to join me to talk about Cosmos DB, which we just watched a little video on. It is a globally distributed database service within Azure that allows you to create NoSQL databases, access them extremely fast, low latency, high throughput, consistency, you name it. There are all these different models. My guests today are going to tell me all about it. And so I'm going to bring them both in one at a time. First, I'm going to bring in Gahl Levy. Hi, Gahl. How are you?
Hey, everyone. It's great to be here. That intro was amazing. I loved
Thank
it.
You. And also, I'm going to bring in Theo Van Cray. Hey, Theo. How are you?
Hello. I'm good. How are you, Jay?
I'm great. So where are the two of you located? Where are you broadcasting from today?
I'm in New York City.
Oh, me too. I'm in Brooklyn.
And
Same. Also in Brooklyn.
I'm in a tiny little town called Wesham in the northwest of England, so the UK.
Well, we are, multi-continental today, but New York seems to have the big lead on where we're from. So we've got a really cool episode that we're going to talk about today. We're going to spend a lot of time on Azure Cosmos DB. We don't have a lot of time, but the time we have, we're going to spend on doing that. And before we get too much into things, I want to remind everybody of a few things. One, we've always got a poll, and we'd love you to take this poll. I think it'll help set some context for my guests about who's watching and what they're watching for. And this week we've got, are you currently using NoSQL for your applications? I'd love to know a little bit more. You can vote yes, no, or it's complicated. It's one of my favorite answers. And then we've got the docs for today's show. So all the documentation that you would want to point to, the Learn module, which I absolutely recommend you go and check out. You can get this free education right within Microsoft Learn. It's gamified, so you can have points. As you can see, I am an 8900 XP wizard on doing things with Learn and Cosmos DB. So that is the big the big intro, guys. Next, we're going to kind of get into you for a minute. And so I want to remind everybody, if you've got questions and comments, you can send them in the chat, whichever chat you're using, and that includes the native chat within Learn TV, so aka.ms/Learn TV, or if you're watching on YouTube or Twitch, you can send them that way. So I want to ask you both a little bit about your background, how you got here. And so I always ask that question, and I'm going to ask Theo first, if you just tell me a little bit about your background and how you got here.
Yeah, so I don't know how far to go back. I'll just go back to when I started in tech, I guess. I started as a software engineer working for a big insurance company. I don't know why I'm not saying who they are. It's AXA. I worked for AXA for quite a long time. And then I worked in government in the UK as well, moved into a role as an architect. And then I came to Microsoft. In between those roles, I did a master's degree in data science. So I was getting into distributed data platforms, NoSQL and big data. And I kind of developed an interest in those areas, and then I worked in the customer success unit as a cloud solution architect for a couple of years before joining the Cosmos DB team. Although really I was straight on to Cosmos DB from day one. I think it was just being released at that time, so there was a lot of buzz around it. There still is a lot of buzz around it, and so yeah, it feels like I've always been working on it, but really it's only been sort of 2, 3, 4 years. Now, so yeah, that's me in a nutshell.
And watching the product kind of grow has been very, very impressive.
Yeah.
So, Gahl, I've got the same question for you. How did you get here?
Sure. Also in my mind, I'm thinking, how far do I want to go back? But in terms of career-wise, I started off my career in software engineering at DataStax, actually working on Cassandra, and eventually I transitioned over to PM. And now I'm a PM at Microsoft, still working on database software, just working on the API for MongoDB. In between, I did an MBA at UC Berkeley.
Cool. That's great to learn a little bit both about your background. I think it's always helpful for everyone to kind of get some context set about our subject. And so, speaking of getting some context set around our subject, I'd love to learn a little bit more. I'm lucky enough, I know some stuff about Cosmos DB, but both of you are working as people on the product team, getting things out there about how to improve, use all these things, your applications with Cosmos DB. And so I'd love if one of you wanted to give me a brief intro and some information that you feel like you want to set context with. How about you start with us, Gahl?
Sure. Do you mean like context on Cosmos DB or on the product in general, Cosmos DB?
Yeah, Cosmos.
Yeah, so Cosmos DB is a globally replicated database platform that's multi-model, meaning there are different APIs that can be used to access it. And what's great about that is, as a developer, I don't have to learn a new database format, basically, in order to use Cosmos DB. I can use a database format I'm most familiar with. So for example, MongoDB or Cassandra, I can use the API and the same applications as I was using before and not really have to change much of anything in order to leverage the benefits of Cosmos DB. Obviously, we also offer the SQL API, which is the native API for Cosmos DB, but that's not the only option.
Gotcha. And so you're using these different APIs like you would say through any of the other native. So if I'm using the SDK that MongoDB releases in order to actually connect an application to it, you don't have to make that modification. It's more like a connection string change, if I'm right.
Exactly. And from the client's perspective, you're still using a MongoDB database, but you're actually using Cosmos DB and leveraging all the benefits of that.
Sure. So you said that you've focused on the MongoDB portion of things. And I got a question for you about that. And Theo, you'll be able to give me a little bit on this as well. So if I'm building a new app, should I choose the Cassandra or Mongo API or the SQL API? What do you believe is the right move? And Theo, I'll ask you to jump in as well after we hear from Gahl.
Oh, really? I'm biased with obviously working on MongoDB, but from my perspective, if you're a MongoDB developer and you've gained those skills of using, the MongoDB drivers and the tools and all that, you probably want to keep using that knowledge you've gained over time and not have to totally, change your way of thinking, basically, and not have to change your apps. So if I was a MongoDB developer, I would use the MongoDB API on Cosmos DB because I still get the benefits of Cosmos DB, but I don't have to, learn a new query language. I can keep my apps the same as they were before and just use a new database platform on top of that.
Gotcha. And Theo, same question. If you were building an app, why would I select Cassandra as opposed to one of those other APIs?
Yeah, it's a really great question. It's one of those questions that kind of demands that you start with that horrible "it depends" response. It depends where you're coming from. I mean, if you're at one end of a spectrum where you're really wanting to solve for performance, let's say, and efficiency, it would be difficult to look past the core API, the SQL API, because that's that's really the cloud native platform. That's where it started. All of our platform level features usually ship there first. So in terms of pure cold performance, that's where you were going. You'd have to recommend that. But then again, that's not to say that the other APIs aren't kind of close to matching it. And there are other things that come into this as well. Like Gahl just said, if you're coming from a different developer space, it's not just about the platform, it's also about the programmability and developer experience as well. And of course, Mongo and Cassandra, much as we'd love to embrace, the SQL proprietary standard, they are open standards, and that tends to be important to a lot of companies who are, having multi-cloud strategies and so on and so forth. So it's a complex thing to answer. It's not something you can really recommend to somebody. It really depends on where your starting point is. So yeah, I like Gahl's answer. If you're coming from a place where you really like the Mongo experience or the Cassandra experience, choose those. If you're really pure greenfield and starting from scratch, and especially if you want to really solve for particular performance characteristics, then yeah, you may want to take a look at the core API.
Gotcha. Thank you so much, both of you, for those answers. I really do appreciate getting that little bit more context set. So one of the things I'd love to learn a little bit more about are some common use cases. If you'd like to talk about it just for a second, Gahl, if you'd like to just give me some, say, common use cases for the MongoDB API.
Yeah. So I guess common use cases for the MongoDB API are ones that leverage Cosmos DB's benefits. So the ability to use, MongoDB and pretend as if Cosmos DB is a MongoDB database, but also scaling is a major factor. So the MongoDB API on Cosmos DB is able to scale instantaneously within less than a second. And that's a real benefit because sometimes people have applications that don't actually use all the scale at once. They kind of go up and down depending on the time of day. And you don't want to delay when you need that scale. You want it immediately. That's a major, major use case for us.
Gotcha. Theo, same question relating to the Cassandra API.
Yeah. I guess where Cassandra differs, the main area where it differs is it has a schema. It's the only API that does. So if you're particularly attached to having a schema, and there's lots of reasons that you might want to have the schema at that layer, then you would use Cassandra. Also, similarly, performance, order catalog type scenarios, or even IoT type scenarios where really throughput and is important, latency is important, availability is important. Actually, all of the APIs are sort of common in that respect. Where the differences are, and is it, like we said before, the developer experience. But where we generally see use cases across the whole of Cosmos DB is the things we already talked about. The kind of where you need great performance, IoT type scenarios, retail scenarios, ordering, comparison website scenarios. I would actually say that between all of the APIs, you have a pretty general purpose set of functionality there. So there isn't really a use case that I could say you couldn't use a Cosmos DB for that, or there wouldn't be a way of really optimizing it. But it is a distributed database, and so if you were coming from the relational world, then there'd be some learning to do at the very least. Even though I would confidently say that you could apply your use case very well to it.
And sure. So one of the things that you said is distributed. So that really lends to, say, very globally diverse types of applications that may be having different endpoints, or I should say user bases in different parts of the world. So having, edge locations that are distributed that you can replicate your data to, I'd imagine is kind of crucial in being able to really get a lot of the benefits. And I know that there's multi-master reads and writes, so that if you're in a different than like whatever you've initially created, a different region, you can write to multiple regions, and then you can pick your consistency level. So eventual consistency, session, things like that, they all become available. So Gahl and Theo, I know you both have a little bit of presentations to show me. We've got about 45 minutes or so, maybe a little less, to start going into them. And Gahl, I'd love you to kind of jump into what you've prepared for today.
Sure. If it's possible, can you please share the slides I have? Yeah. So I kind of wanted to drill in a bit on the scale, because this really applies to all of Cosmos DB. So we said, Jay, you mentioned we have regions all over the world, and you're able to scale up and down based on user demand in those regions, as well as have very high availability. We offer up to 5 nines of availability because of the multi-primary rights feature. And when I say like scaling, I don't just mean scaling. So not just scaling VMs. Since we don't have a concept of VMs, we essentially sell throughput of the database. And the reason for that is because we're a multi-tenant system, meaning that we have a huge pool of resources that we can allocate resources and throughput to you at any second, very, very fast to you as you need it. And you only pay for what you need. So that allows you as a user to scale in fractions of VM of granularity, meaning that you're only paying for what you use, and you can get all the scale you need whenever you need it, which also means you don't have to pay when you actually don't need it. So
if I'm right, the pricing module is based on request units, which are basically IO utilization and throughput that you're actually making use of. And I know there's like 2 different models. There's a reserved unit and a serverless unit. And I'll give you some time to go through that.
Yeah. So on that note, imagine you have a use case similar to the one in the middle here, where your workload is spiking up depending on the time. If you're using VMs, you would have to wait, to achieve cost, effectiveness here. You'd have to wait. Imagine blocks of time as you scale up your VMs, up and up and up in blocks, and then down and down and down. With Cosmos DB, you don't have to wait for those VMs to scale up, and don't have to over provision. You just pay for what you use, and you scale up exactly. You follow that line much, much closer than you would with VMs, and that saves you money. One, and most importantly, it gets your users the performance they expect. Your database does not slow down. You always get 100% performance for your database because of this, because we have giant pools of resources we can allocate to you immediately. What you mentioned with reserved instances is very applicable to standard provision throughput. The slide you see here is the 3 different ways we have provisioning resources in Cosmos DB. With standard provision throughput, that's where you kind of set the limit of how much request unit budget you need for your database. And this is very good for workloads that are very consistent. So if you always need around 7,000 RUs, you can have that 7,000 RUs, pre-provisioned as resources, and know that you can save money with that because you don't really need to change that often. However, if you have a spiky workload, autoscale is a great choice because you only pay for the resources you provision, and you'll scale up and down instantaneously depending on what you need. And the last one here is serverless, which is GA now on the API for MongoDB, where if your database is idle, you pay nothing. You pay 0 for that, and you only pay for the RUs you actually use. And that's really good for sporadic workloads or dev and tester workloads where you only you use a database like once a week or something like that.
Gotcha. Very, very cool. Like those, being able to pick a pricing model around these different things is really important, I think, for our users, because you have to be budget conscious when you're working with a globally distributed database, I'd imagine, rather than just, spinning things up and not worrying about what things cost. That's not something that people are really interested in doing. And one of the things that I've really enjoyed about Cosmos DB is how it's really empowered the developer, because there's way less management of the underlying systems that you would have in traditional database administration work. And so now you can have DBAs within your team kind of readjust their workflow. So maybe that they're more focused on making sure that the indexes are right and ensuring consistency levels are right, and working with the SDKs to work with backups and restorations and things like that. All that, I would imagine, really helps give the developer a bigger hand in the situation.
Exactly. And one great case of that here is you can even switch between throughput models on your same Mongo API collections. Between standard and autoscale, you can change. And that's why we always recommend for users to start off with autoscale first, see where their workload patterns go, and then switch to standard if they feel like that will save them money. So it's up to the developer to choose which one they prefer. One great case of where a lot of this operational workload is lifted is essentially, with sharding. So sharding is very important because it allows you to horizontally scale your database. And in Cosmos DB, sharding or partitioning is native. It's a cloud native database, and it's built to horizontally scale as much as you want. And unlike in the MongoDB case, unlike many other MongoDB services, Cosmos DB manages the sharding automatically for you. As long as you choose a shard key or partition key that evenly splits the data, which is something that these people you were speaking about, like DevOps folks, can really focus on that instead of the actual sharding aspect. As long as you choose the right partition key, the sharding key, Cosmos DB will automatically shard for you and scale up and down to your needs, and not just scale a little bit up and down, scale unlimitedly, like as much as you want. There's no limit there, which is really amazing because it manages all this for you. You don't have to decide how many shards you want, and you don't have to pay for the metadata service to manage that. It's all done automatically for you by Cosmos DB. And that's one of the benefits of building your MongoDB apps on the API for MongoDB on Cosmos DB.
Very, very cool. And one of the questions I have is, how long does it actually take to auto scale or to scale up that database that I might be using?
Yeah, so since we have a giant pool of resources that allocate things to you instantaneously, your scaling is instantaneous. There's no wait time. Your users don't have to wait, and you only pay for what you're actually using at that point in time. So it's really the best of both worlds there. And that's with the autoscale model that I mentioned right here, the middle one.
And one more question is, why is the API for MongoDB just more efficient than, say, other MongoDB offerings? So
first off, it's more efficient first because that entire operational kind of workload of having to manage sharding and the deployment and upgrades and all that is taken away from you. Sharding is done automatically for you. Upgrades take seconds because we don't run any MongoDB Inc. code. We act as if we're a MongoDB database and implement the wire protocol for MongoDB, but all of our versions are in one code base, and to upgrade between versions, it's just feature flags on or off, and it takes seconds to do. That's one aspect of efficiency. The second aspect is that we have that giant pool of resources that we can allocate to you effectively whenever you need it immediately, meaning that you're only paying for the resources you use instead of over provisioning VMs and waiting for your usage to catch up and then over provisioning again to make sure that you don't get a degradation in performance.
So rather than, say, going with another offering from another company that is basically leveraging virtual machines or containers on the platform. So, GCP, AWS, or even Azure, rather than letting a third party in. And I know MongoDB, they have their own service. It works great, but it's still running on top of somebody else's cloud, as opposed to this, which is native to Azure.
Exactly. Imagine you have a request. Doesn't matter what kind of request it is. In Cosmos DB API for MongoDB, as your load goes up in a VM-based kind of framework, as your load in the VMs goes up, your requests get slower and slower and slower until they eventually can't go through anymore. In Cosmos DB, the idea is you want to have 100% guaranteed expected performance for each request, and you'll get that. And when you need more throughput, you can pay for more throughput. You can autoscale to that throughput immediately. So your requests always behave in the same expected way, and there's no surprise when suddenly a bunch of users start using your platform, your app, and then your performance for your database just goes way down because you weren't prepared.
Gotcha. So one more question for you, and then I'd love to hear a little bit more about Cassandra, unless you've got more to show us. I'm curious, you mentioned about all those different features and upgrades that you've got there. And I was just curious, how do I upgrade my database account? Because I know Cosmos DB kind of has this hierarchy of like account than the actual container that you're working with.
Yeah, so upgrades, actually, I'll go back to this slide because I like this slide because it has a cat and I have a cat. So I like talking about cats in general. I have a cat, and if my cat needed to upgrade my database, my cat would be able to do it because it's literally one button press in the portal or programmatically it can be done. And there is no, the database stays online. Everything keeps working just as you expect. You just get to leverage those new features immediately. And you just to demonstrate this, you just go in the portal, click this button, set the version to whichever version you want, and then your database starts working that way with every new connection. And to top that off, with those feature flags, you can even undo the changes if you decided to do that. You can go back and downgrade to a different version. And because of the way our code base is structured, we're not limited to end of lifing older versions. We just have all of our versions in the same code base, so we can just keep them running for as long as we want. And you can upgrade and downgrade between the versions you want to get the features your app desires, basically.
Well, I am a dog person, and my dog is very, very excited to be here in my apartment and home. But so thank you very much. And so I'm curious, Gahl, is there anything else you'd like to show me before we head over to Theo so he can show us a little bit more about the Cassandra?
Would this be a good time to demonstrate just one quick thing with Robo3T?
Yeah, sure.
Sure. Let me just share a different screen here. Just give me one moment, please.
Sure. And to remind everybody, if you've got questions or comments, use the chat, ask them now. And if you haven't already, take the poll, please. Go to aka.ms/learntv to do that. All right, Gahl, I'm going to bring up your screen, and you've got Robo3T, which I know is a tool to actually browse within databases.
Exactly, yeah. And I just wanted to demonstrate, this is a Cosmos DB API for MongoDB database and collection here. You can see the collections they have. And I want to demonstrate how these collections work in the same way you expect, as if it's a MongoDB database, but it's not. It's a Cosmos DB database with the API for MongoDB running on top of it. But all the tools and all the SDKs work as you expect. And that's really, really important because as a developer, I don't want my app to have to change. I want it to stay as similar as possible and just leverage all the benefits we just mentioned of Cosmos DB. So you can see, I can go into this demo collection and just double click on it and see some documents. Everything works as expected. I can insert documents. Let me just insert a document here. In this case, this collection is sharded on user ID, can validate, and I can insert it, and everything works as expected. And this is the same experience we want everyone to find with their tooling, because we want the experience to be the same for developers, but at the same time being able to leverage the benefits of Cosmos DB as well.
Very cool.
Yeah.
And then we have our keys and our values and everything that we would expect, along with that incremented ID that if you don't necessarily specify your own ID, you can just have Cosmos create your incremented ID, and then you just when you're creating this, you're indexing on one of these fields and having Cosmos, or I should say, you're having a shard key set on one of these, and then you're letting auto indexing kind of happen, and you don't have to worry about managing data distribution. You just pick where you want it to go and let Cosmos move your data across.
And you can see we're indexed here on. We have indexes for ID and a wildcard index as well. So
very, very cool. So unless you've got anything else to show me, I'd love to hear a little bit from Theo and see what I can learn about that Cassandra
that's all my
offering.
Thank you.
No problem, Gahl. Thank you so much. So Theo, thank you for giving me some time. I've got some questions about the Cassandra API. And the first thing is, I know that there's Cassandra managed instances that exist on Azure, but I'm curious, is that part of Cosmos DB, or is the Cassandra API a separate offering?
Yeah, so the answer to that is yes and no. It is part of Cosmos DB in the sense that it was built by Cosmos DB team, and it also reuses the Cosmos DB control plane for all of the automation that we do. But it's actually a separate product. It runs open source Apache Cassandra, and we automate deployment and scaling and maintenance on that. So it's a separate offering.
So is it kind of like the same relationship that, say, SQL Server for Azure or Azure SQL has to, say, an SQL managed instance?
Exactly.
Is that kind of like a one-to-one there?
Yeah, you got it. It's the same idea. Yeah.
Great. So I know, Theo, you've got some stuff to kind of present for us, and I'd love to take a look if you mind me bringing your screen up.
Sure. Yeah. Let me know when you can see it, because I can't see it.
Okay. Cassandra, the cool bits.
Yeah. So I wanted to talk a little bit, just a little intro, I guess, to Cassandra. What's good about it, what's not good about it. What's good about it is pretty simple. It's performance, right? It's distributed, linear scale, write optimized, fast reads. It's very resilient, fault tolerant. It's actually pretty easy to use as well. The learning curve, at least from the developer side, I should say, is easy. What's not so easy is maintaining it, right? So the back end and replication settings and different configurations and just running the platform in general can be difficult, which of course makes it a great candidate for being an API on Cosmos DB. Cosmos DB at the back end is pretty similar architecture, so it makes it relatively, I don't want to say too straightforward. I don't want to make it seem like it's too easy, but we can surface this API, and much as Gahl was showing there, all of the SDKs and things that you would expect will work. That does depend on feature supportability. So we don't support 100% of everything that you would expect. So we definitely recommend reviewing our docs to see what things we support and what things we don't support. But we're bringing new features all the time. And usually by features, what I mean is things that are already expected in Cassandra, but we're adding them to this API so that, it can be completely feature complete. So things like materialized views in private preview there, lightweight transactions is now in public preview. Truncate, named indexes, clustering key indexes are now in private preview as well. And then we have the type of features that we call kind of unique to Cassandra API. So change feed is something that's unique to Cosmos DB, and it's a programmability model for being able to do event sourcing type applications. And feed ranges is a way of doing that with processing in parallel for very large types of workloads. And we've also got server-side retries now in GA as well. And there's some features we're working on right now. So we're working on native RBAC, which is the role command in Cassandra. Again, it's something that you expect at Cassandra, but we're adding feature compatibility all the time. And then there's things that are, again, unique to Cassandra API. Point-in-time restore is a feature that's in the platform that we're surfacing in the API. And we're working on a public Azure search, Azure cognitive search integration as well. And then there's Cassandra Managed Instance, which I'll probably talk about a little bit more later as well. We're adding some new features there, and there's some stuff coming also. But what I wanted to hit on was a question that as you can imagine, we're obviously getting quite a lot since Managed Instance went GA last November. How do you choose, or what would we recommend? And the answer to that is really, it really depends where you're coming from. It's a bit like the answer to the other question, which API should you choose? But specifically here, when you're choosing between two offerings that look very much the same or similar, it's really a spectrum between control versus productivity. So it's very much like I guess the choice between running IaaS implementations and applications versus using PaaS services generally. Of course, if you're rolling your own stuff, you've got a lot more control, but you've got less productivity, and vice versa. When you have a lot of productivity, that you might not be able to do certain things that you expect, or you need fine-grained control. And what this kind of boils down to, the analogy that I think Scott Hanselman first used, and I've stolen it ever since, is this kind of think of it like an Uber or a manual or an auto shift. If you need a car to go somewhere, and you can't get a bus or you can't get a train, you need a car for whatever reason, but you don't have a driving license, or you don't have a car, or you can't afford one, then obviously Uber is going to look great to you. But if you have a car and you have a driving license, then obviously you're choosing between a manual shift and an auto shift. And that analogy kind of works for me, because there is this kind of line between these types of offerings, or self-hosting, I should say, and the kind of managed hosted platform version of Cassandra versus something like Cassandra API. You're still in control of the platform configuration aspects. There might be more automation in Managed Instance, but you're still in control. With Cassandra API, Microsoft really controls all of the platform level stuff.
Gotcha.
Yeah. Did you have a question?
No. It's just,
yeah.
Please go ahead. Continue.
Yeah, and so what we're adding to Managed Instance over time is what I like to think of as semi-auto shift. So more things that you can control. But if we take the analogy further, of course, there's always going to be certain things that we're always doing, right? Otherwise, it's not really a managed service. So deployments, OS patching, and scaling, and so on. So what this is really about is trying to give users who like Cassandra as much choice as possible. And again, it's the same thing. There's always a trade-off. It depends what your starting point is, and so you have this kind of choice.
Gotcha. So
I wanted to hit migration, and I've got a bunch of demos, so we'll see how they go. Migration in this context, just to be clear, I'm talking about like for like. So where you already have, let's say, a self-hosted version, or even a managed version for that matter, of some flavor of Cassandra. So you're not migrating from, I don't know, MongoDB or something into Cassandra. You're migrating from a flavor of Cassandra, but you want to migrate into either Managed Instance or Cosmos DB with the Cassandra API.
Sure. So if you're using data stacks and you want to bring everything over to Azure, that would be kind of a one-to-one, just using the migration tool.
Right, exactly. And even there are challenges with migration. Migrations are always a challenge, right? So, and especially live migrations, which is what I'm kind of focusing on here. The nice thing with Cassandra Managed Instance is what we've done as a managed service. We have kind of had this unique capability of allowing people to configure hybrid clusters. So what that means is if you deploy a managed data center in a Managed Instance for Apache Cassandra, that data center can join an existing self-hosted cluster ring in your own self-hosted version of Cassandra. So what you'll have there is self-hosted on-premise or in the cloud, wherever it happens to be, and then a managed data center in the cloud. And just to kind of give a quick, I guess, demo of this, it's more of a Blue Peter style demo. English people will know what I mean by that. But yeah, here's one I made earlier. This is a resource group in Azure, and I have deployed an open source Apache Cassandra cluster, and I've got this thing here called Azure Managed Instance for Apache Cassandra, and it's this cluster resource. And what this is, in the case of hybrid clusters, is kind of like a bookmarking resource, so that the system knows that any data centers deployed for a managed instance, in this case, are going to join an existing clustering of this name. And so what I have here, if I look in my, where is it? No, let's go back into the cluster resource. If I go into my data center tab, I can see information about my managed data center here. But there's also a self-hosted data center, which if I go into the node tool, use the node tool command from one of the nodes on there, I would be able to see both my self-hosted data center here and also the managed data center here. So that might be something that seems a little bit weird. Why do we do this? Why are we kind of mixing and matching self-hosting with the managed service? And obviously the reason is quite obvious. For people who want the easiest, most seamless way possible of migrating, let's say from a self-hosted or on-premise Apache Cassandra cluster, there's nothing better and more seamless than actually using Cassandra replication, joining your data center or your self-hosted data center with that managed data center. It's a form of hybrid, and then everything is just seamlessly replicating. And similarly, it doesn't have to be used for migration. It could also be used just as a way of extending your capacity. If you're comfortable where you are, whether it's self-hosting or on premises, and you want to use Azure as a kind of on-demand way of scaling up and scaling down elastically, then this is a great way of doing that as well, because we provide automation around deployments, not only, but also scaling of up and down of nodes as well within your managed data center. So that's why we've done that.
It sounds like a good disaster recovery option for people who need to have multiple places that their data needs to live, or if they're in a scenario where only a certain amount of data can actually exist in Azure based on compliance or regulation, and then they can have the other portion of the data, say, hosted in their own data center.
Right, absolutely. Yeah, it gives you flexibility. But if you're not in the space where you can do that, where you're not running a version that's close enough to the versions that we support, or you can't do a hybrid cluster for whatever reason, maybe you're using Cassandra API or some wire protocol version of Cassandra that doesn't support connecting up to our service, then the approach that we recommend and we see a lot of people use is this thing called dual writes, or double writes as it's sometimes known as. It's not really a new way of doing migrations. So where you have, let's say you have data that's being written to the old database over a timeline, let's say, and you start by migrating the schema, what you would do is configure your app to write to both the source database and the target database. Typically, when you're writing to target, it would be asynchronous. And then if necessary, you'd also have something that would be migrating or copying the historic data, because obviously you can't guarantee that all the updates are going to hit existing data. If your retention is short enough, then you just leave it running, and then eventually the data in the old system becomes irrelevant. But if it's not, if it's very long, then you want something that migrates all of the old data as well. Either way, you're going to get to a point where you feel that your databases are in sync, and then you can validate that the migration doesn't have any errors and no records missing, and then you would cut over at that point. So that would be that pattern. The problem with this pattern is this stage, right? Configuring your app or changing your app and changing the code to point to different, a different target, and everywhere where you're doing updates is, maybe a little bit invasive. And if you've got a lot of applications hitting the same database, obviously that's not very convenient. So what we've done is developed an open source tool, which we call the dual write proxy. And this is a tool that you can install on an existing Apache Cassandra cluster. So you'd install, it's just a piece of Java software that you install and run as a process on each node on a given existing cluster. And when that's running, all you have to do in your application is just change the port. You don't have to do any other changes. And then the proxy will then route both requests to the local node and also the target Cassandra system, whatever that may be, asynchronously. So this is a way of doing the dual writes process, but taking away a lot of the pain and concern and the friction and so on. Then, of course, what we recommend for doing the data copy is using Spark with the Cassandra Spark connector. In this case, you'd have to either backdate or preserve the original write time so that when it's being copied over, those records don't overwrite anything that's being updated live via the proxy and so on. For this demo that I'm about to do, I'm going to use a sample that we can share that preserves the write time, but it also has a routine for doing validation and then correcting any errors that come up as well. So yeah, the moment of truth. Let's do this. So what I have, let me go to my resource group first. In fact, let me go to my app first because there's something I need to start running. So what I have here, it's just an app that I'm going to run, and all that is doing is just dumping 100,000 records into my source database and table. That's going to simulate, data that's already there. Of course, you might have millions of records, but this is a short demo, so I'm just going to dump 100,000 records there. And so while that's happening, let me go and look at the resource group that I have. And again, like with the other hybrid cluster that you saw, I've just deployed a vanilla open source Apache Cassandra cluster with 3 nodes. And then I have a Cosmos DB account in here, a Cassandra API account that I'm going to end up migrating to. And I also have a CQLSH tool, which is the tool for interacting with Cassandra. So I'm connecting to my source database here. And then I'm just going to do a count. Hopefully that data has been dumped in there. There we go, 100,000 rows. And much like you saw with Gahl demonstrating the Robo tool, I'm using exactly the same tool to connect to Cassandra API. The tool works in exactly the same way. All of the drivers, all of the open source tools that you can think of, they work pretty much in the same way. While their feature compatibility might not be the same, the wire protocol is the same. So all of that developer experience is still preserved. So when I run count here, I've got no records. Obviously, I'm about to migrate something. So let me go back to my app here. That's obviously finished now. What this is going to do when I hit enter is it's going to simulate updating some of those records, various randomly of those records that I inserted, but also adding new records as well. So let me start that running here. And then if I go back to my source table, obviously I should see, let's go back to the source window. I should see the count starting to increase. Obviously, there are inserts going in and records being updated. And if I go, what I didn't mention before is that I have installed the proxy already, and the app is now pointing to the proxy. So you can see some activity there. It's connected, and now it's routing requests, or should be routing requests, to Cassandra API. And if I go into my target table, I should see some records starting to appear, which is great. I haven't had to do anything except change the ports and install the proxy on the source Cassandra nodes, and then configure it to point to the target. That's all I've had to do. But of course, that's great that I'm getting the live updates, but I want the historical data in this case. So I also have a Cassandra, Spark script here that's going to migrate the data. And this is a sample, again, that we have public that you can use. I've just taken the cells here and put them into some notebooks here in Azure Databricks. So let me just run this thing here.
Sure. And this portion, it's all in browser, which makes it a lot, like, you don't need to worry about local tools to be installed. It's all here for you.
Yeah, exactly. Yeah, there's some code. You have to use Spark and the Spark connector and the libraries that we put together. But yeah, it's pretty straightforward, I think, to interact with, hopefully. So this is running this is going to migrate all of those 100,000 records, and who knows how long this is going to take. Sometimes it's quick, sometimes it's slow. So if you have any, maybe this is a good time to ask another question or.
Sure. So, Gahl, one of the big differences between what you were showing as far as Mongo is concerned and what Theo is showing is the lack of schema that's required in order to actually work with your data. And if I'm right, whenever we need to make some modifications to our application, we may need a new key and value to get stored. We don't have to go ahead and migrate our data to a new version with a new schema. Am I right about that?
From a Mongo perspective, you can basically create whichever documents you want, whichever keys you want. The only important thing to mention there is if you are creating a sharded collection, that shard key needs to stay consistent and needs to be in every single document you insert into that collection. Because, and the reason for that is because the database needs to know how to split up the documents on each shard individually. And it needs to know where to go, basically.
Great. So Theo, it looks like your process finished.
Right, yeah, it finished. And while you were talking there, I also ran this validation routine. And you might think that I'll be alarmed by this, but I'll break the suspense. I deliberately engineered this failure. So there's the 1,582 records that failed. So it looks like there are some missing rows in here. I can see the reasons for failure, missing rows, or some updates didn't make it through. And again, I'll break the suspense. I'll tell you why this failed. What happened is that when I did the data copy, I was saturating the throughput on Cosmos DB. And so when the client was trying to do the requests, it was working fine to the source database, but I'm getting this request rate is large. And this is by far the sort of most likely thing that you'll run into if you're trying to do a migration to any API in Cosmos DB for the first time, and you're used to using something that's provisioned in a more traditional way. Cosmos DB is a request-based currency, so it works on this thing called request units. You have to provision enough for what you need, and if you exceed that amount, you get what we call rate limited. That's something that we could probably spend a whole other show talking about. But in this case, I was a little stupid deliberately. I ran my data copy at the same time as my steady state workload was at its peak. So obviously I should expect to get throttled and not have enough performance there. One of the ways, or a couple of the ways that you could avoid this is, one, you could go into the Cassandra API account, or any account, I believe now. I think we have to support this everywhere, certainly Cassandra and Mongo. Go into features, and you can enable something called server-side retry. And what that will do is during rate limiting, it will actually retry on the server up to a certain limit of 60 seconds. And after that, it will time out. Another thing you can do is in the actual Spark settings, obviously you can limit the throughput that's getting sent through during that period of time. So you could fix it that way. And so that's all well and good, but I've still got a problem. I've lost some records. So how do I correct that? Well, we also have a script here that just allows you to retry those transient failures by just filtering on the failed rows, running the validation routine again, and then running the migration routine to get the records that failed and just sending them again. So let me just try doing that. And hopefully that's not going to take as long as the other things that I've just run.
Great. And just to give you a heads up on time, we got about maybe 5 minutes or so before we got to wrap up.
Yeah, we're good. I think we're going to be good. We're making good time.
It's always fun when you do it live and you have to kind of how many minutes left?
Especially a ridiculously ambitious demo like this. I've engineered a failure on a non-deterministic kind of process. Never mind.
I think you're doing a great job.
Yeah. So it looks like we're about to get a result here. So again, this is retried all of those failed records, and hopefully this will finish pretty soon. Maybe I would. Yeah.
Sure. I was just going to ask Gahl while we're waiting. Is there any real limitation on how much storage I can use for the amount of data that I'm going to be putting into Cosmos?
The storage, yeah. So there's no limit to the storage that you can use as long as your cluster is sharded. You can scale as much as you want. There is, I think there's a minimum number of throughput for the storage, but that can be obviously lifted somewhat depending on your use case. But overall, as long as your database or collection is sharded, you can scale as much as you want. There's no limit there. It's unlimited.
That's great, because one of the more difficult parts about database management is managing the underlying storage and actually being concerned like how much is there, how much is getting backed up, is it all getting backed up? So knowing that this is all done through a PaaS, that you don't have to concern yourself with those things is great. So Theo, how'd everything work out?
Yeah, awesome. So what happened then while you were talking is I ran the retry failures script here, and then I ran the validation to see if I was okay, and it looks like I've got no failures. So I guess the one final check I can do is just run the count on my source, and then run the count on my target, and hopefully it's a similar number or the same number. Great, awesome. So yeah, that's exactly the same. So that was it really for the for the migration. And that was a live migration using completely open source tools, the Cassandra migrator sample for the Spark connector to preserve write time, and also the dual write proxy. And in this case, I did it for Cassandra API for the first time. So if you want to know how to live migrate Cassandra API, this is how to do it. We've got this documented as well. If you want to repeat this process, and reach out if there are.
Yep. And the Cosmos DB documentation I've got up here, and I'm going to take your screen out now, Theo. The documentation is up here at cda.ms3j3, where you can go and you can get all the information on Cosmos DB, including all the documentation. There are some tutorials, some code samples, a reference guides, links to, say, the different API SDKs that you may need for the different types of APIs that there are. And we only touched on two really today, Cassandra and Mongo. We talked a little about, there's the SQL one. There's also Gremlin for graph databasing. And then, of course, Table for just pretty simple storage of, like, say, keys and values. So those are the big ideas, and we're just about out of time. And so I just wanted to start by saying I'm going to bring up this little bit of background just so we can close with some nice music in the back. So first, Gahl, can you tell people how, if they'd like to reach you and talk about anything on the internet, where they can?
Yeah, feel free to reach out to me on LinkedIn. That website goes straight to my LinkedIn, so feel free to send me a message. Always happy to answer questions. And the docs page for the API for MongoDB on Microsoft Docs is a great way to get started.
Great. And Theo, same question. Where can people get in touch with you to learn more about Cosmos DB or reach out with questions?
Yeah, you can reach out to me on Twitter, but I almost never use it. So technically, you can reach out to me. My handle's there, but reach out to me on LinkedIn as well. It's easy to find me. I think I'm pretty much the only Theo Van Cry in the world, it looks like. So you put me into Google, and I seem to pop up straight away.
Well, very cool. So, gentlemen, I want to say thank you so much for being part of the show today. For those of you watching, if you go into the show notes, you'll be able to get a full list of links of different documentation that you can check out. And there's also a link to the free tier info on Cosmos DB. So if you want to get started, you don't want to spend a few bucks on it, you just want to see where it takes you. Maybe you want to just create a couple documents and see how you can access them or modify them. Give the free tier a try. Anyway, gentlemen, thanks so much for being part of this today. I know it's in the evening out there, Theo and Gahl. We've got a little bit of our day left. I hope you stay warm. It is absolutely terrifyingly cold here.
Yeah. Thank you so much for having me on the show.
Thanks, Jay.
No problem. So, guys, let's give everybody the big wave goodbye. And I will catch you all next time here on Azure FunBytes. Thanks for watching. See you soon.